So according to the previous table, we can see that the schema versus the instance, we can read them in a table just like the column versus the rows, right? So generally given a table, for each column, we can find the attribute of the relation, right? And for each row, we can find the data instances inside the tables. So we can read the table in this way. And in this page, we want to show you how to represent a relation formally. Generally, we can define a relation by representing them as R with parentheses with A1 to AK denoting the attributes of the relation. So this R denotes the relation name. Its A1 denotes a attribute name. And we also need to indicate the type of the attribute as well when we define a specific relation. This A2 is another attribute name. It should also be followed by some types of these attributes. This AK is a case attribute of this relation. So we can also provide an example how to define a relation and write down them on a paper. So for example, if we want to define a relation for the product, we just showed before, right? We just showed the product in the previous page. As shown here, so given product, we have 4 attributes. Name is a string, price is a float number, category is a string, manufacturer is also a string. Right? So we can define the product as a relation. So this is a table. We can also represent its schema as a relation like this. So we can have products. This is a name for the relation. Right? It has 4 attributes. The first one is a name. It should have a type. Its type is char, for example. We can give the max length for the name string. Now we can give it is the 20. The length is 20 for the product. And it also has a price. Price its type is float. And we also have this category. It is a third attribute. Its type is char. Besides char in the relation model, we can also indicate its type as a VAR char. It allows the product have categories in strings of different lengths. So we can write down them as a VAR char. And the max length will be now, for example, 30. And the manufacturer will be another attribute. It will also be a VAR char, 30, for example. So this is a relation we can define for the products we showed before. And someone may also wonder what's the difference between char and VAR char. We will show these 2 types for the attributes in the following pages of the slides, so you can see the difference clearly. Okay, so this is how to represent the relations. When we define our database tables, we need to define a bunch of relations. We will have so many relations, right? And together we define a schema of a database. Now, given a database, we have multiple relations. We have relation 1, relation 2, and relation n. So each one will be represented as a table. So therefore, when we create a database, we have multiple tables to be created inside these database systems. And each one will be represented as a relation. Therefore, the schema of a database is also defined as a set of relation schemas. And then we have a question. When we create a database system for an application, when should we decide the schema? And when should we decide the instances, the data instances? As well as how often we will change our mind in revising schema and in revising data instances. So when you decide your topic or your application domain, you need to have a brainstorming. Right? You ask yourself as well as teammates, what is your model inside your application? At this moment, you are discussing about the schema, actually. You draw the ER diagram, right? And then do a translation into relations. Right now, we are doing the modeling of the schema, right? It's similar to the class we showed before, right? We define a class, a template for the data we want to model. It is a schema. So when we set up our database system and decide the application domain as well as the information model, at this moment we need to decide the schema of our database systems. How often do we change in our mind? Generally, we don't change the schema very often. Once it is decided, we seldom change the schemas unless it is necessary. And then when it comes to instances, so generally after the schema is defined and set up, and we want to load some data into the database system. For example, we create a product table like this. We set up a schema, as shown here, and we want to load some data into this table. And then we can add some rows into the table, right? So at the time of this application is running, then we can load the data into the tables by either manually creating or the system will generate the data for us. So we can decide the data we have when we are running this application system. How often do we change the data instances? So whenever you are using this application system, you are changing the data inside the tables. For example, once you're logging into the Amazon and purchase some products, then you are creating some new data in order updating some data there in their tables. What you are updating right now is the instances. However, the schema of the tables in Amazon, they are never changed. They are always the same, right? And you may wonder why we don't change the schema very often. The main reason is because once the schema is changed, even a very minor change, it will create lots of changes inside the system. The main reason is because we will have lots of data there. If the schema is changed, all the data you need to update it accordingly based on the new schema you have, right? Maybe we can think in this way. After we define a class and we create so many objects for it, like 1,000 objects for the class, and later on you decide to update or change the class by either adding or deleting some features or attributes, then all the objects need to be updated accordingly based on the new class. This workload will be very heavy, right? So therefore, we don't change the schema very often for our database systems. And when you are doing the brainstorming with your teammates, you need to have a very thorough discussion about the information model. Then we can have a very mature schema to build for our database systems. In this way, you don't need to change the schema later, right? It is also a reminder for you when you are working on your project. If you have to change the schema in your project, do the changes as early as possible. Because later on, if you plan to change it, it will be a headache for you. It's very hard to change once you have data loaded there. And sometimes you probably have to delete all the data you load into the systems, and it will be a great loss for you, right? Therefore, design your schema as early as possible. If you have to make some changes, also change them as early as possible as well.